Morning. I'm Nirosh Kumar from Pragati Engineering College, working as Assistant Professor in the Department of CSC. Today, we are going to see the concepts inheritance and abstract classes. So let us see what is inheritance first. See, generally, inheritance, the word inheritance itself says clearly that we are inheriting some properties. As we are kids to our parents, we are going to inherit certain properties of our parents. Either it may be genes or like real properties. So, generally, genes, when we acquire the properties of genes, we just look like our parents itself because it is just because of the genes that we have acquired from our parents. See, not only the genes, whatever the properties, the real properties like land or something else, whatever the parents have, definitely the kids will be having their own properties like inherited that are inherited from parents. So just like that, we are going to see the inheritance concept in Java programming. So it is the ability to derive something specific from something generic. So we ourselves will be having certain properties, we ourselves will be having certain properties, and not only that, we are also going to have certain properties of our parents. See, generally, we will earn something and that is ours. And not only what we are earning, we are also going to have something that will come from our parents. So that is what is called as inheritance, acquiring properties. Likewise, something specific that what we have, and not only that, something generic that is what our parents are going to have or will be having. So all that we are going to acquire, and it is helping us to reuse the code. See, we can reuse multiple number of times. We can use certain lines of code to show that properties of inheritance. And the third one is a class can inherit the features of another class and add its own modification. See, even a child can inherit the properties of parent and he can add some more things to the inherited property. Just like that, we can also write code or we can also execute certain programs which will acquire the properties of parent, and also by acquiring whatever that is acquired, he can or add something, do modifications to that acquired property. Next one is a parent class is a superclass and the child class is known as a subclass here. So obviously the class that acquires the properties of a parent is called as child class, and the properties that are given to the child is called as parent class. The same parent and child, the features, likewise we are going to use the same concept like parent and child class. Here we call as parent class as superclass and child class as subclass. That's the only simple difference between parent class and child class. And subclass inherit all the properties and methods of the superclass. So not only the properties or variables or something else, we can also acquire the properties of parent like methods also. So whatever the operations that parent is doing, the child will be doing. So generally people says you're just doing like your father or you're just doing like your mother. It is just because we have acquired the properties of our parent. So whatever the operations that they do, the parents do, similarly the child will be doing the same operations, just like how father behaves or how mother behaves. Likewise, a child is going to behave. The same way, the properties of a child class, that what we are going to develop, will be performing the same operations like how the parent class or super class is going to perform. So that is what the difference between superclass and subclass, and acquiring the properties of superclass by a subclass. This is what we call as inheritance. We can clearly understand by this picture. Here we can see this is a superclass and subclass 1 and subclass 2. See, a father will be having two kids, like one kid, subclass 1 kid and subclass 2 kid. Likewise, we can have any number of subclasses for a superclass. One subclass can acquire properties of parent class. The other subclass can also acquire the properties of the same parent class. That means a parent can have any number of kids, any number of subclasses. So any number of, not only here subclass 1 and subclass 2, there will be any number of, n number of subclasses can acquire the properties of one single parent class. This is what the simple architecture to show about inheritance concept. And see, we are going to see different types of inheritance. Different types of inheritance. One is single, second one multi-level, third one multiple, and fourth one hierarchical, and the fifth one is hybrid. So let us see in detail about each and every inheritance concept. The first one, classes can have only one base class. See here, the base class is A and the subclass is B. So here the superclass can also be called as a base class or parent class. So there are three naming conventions like base class, superclass, and parent class. And the subclass is here B. So whenever there are only one parent and one child, we can treat it as single. We can treat it as simple single inheritance, single level inheritance. And next one, multi-level inheritance. What is this multi-level? See here, in the previous slide we are saying A and B, but now we can see A, B and C. So here, A is a superclass or parent class and A is only one parent here and B is acquiring the properties of A. B is acquiring the properties of A. Here A is a parent class and B is a child class. And now coming to this level, we can see here C is acquiring the properties of B. Now B is acting as parent class for C and C is the child class for B. So here A is having certain properties and that are acquired by B and B is having certain properties and that are acquired by C. That means that the C can acquire the properties of A also. How can we say? It is simple. See, it's father and child and grandfather. So whatever the child is acquiring from his father, it is from his father, that is grandfather. So likewise, the properties of C, the subclass C, can acquire the properties of B and also A, because this parent class B is already acquired the properties of A. That means that C can acquire the properties of A and B also. So this is what here multi-level inheritance. There are different levels. See here there is only one A, B, C. There are 26 alphabets. You can use 26 alphabets here. A, B, C, D, so on, Z. So there may be any number of subclasses, any number of levels here. So that's why we can say clearly there is no limit to this kind of inheritance. There is no limit for this multi-level. Any number of subclasses can inherit any number of superclasses on the above. So this is what we call as multi-level inheritance. And next one, multiple inheritance. A class can inherit from more than one unrelated class. More than one unrelated class. Coming to Java, there is an important point that you have to remember is multiple inheritance among classes is not possible. And that's why it is defined as unrelated classes. See here, A is one parent and B is one parent and C is one child. C can be a child of either A or C can be either a child of B. C cannot be a child of A and B together. C can have only one mother or one father, that is A, or either B, that's all. But it should not have A and B together. This is not possible as in the real world. In the same way, coming to Java programming also, that is not possible. Multiple inheritance among classes is not possible. Let us consider a real world example. If A is the father of C, then C can acquire the properties of A. See, adoption, it is a custom in our culture, and maybe the B may adopt the child C, and this child C can acquire the properties of B also. That means B is not a real father, only the A is a real father. This B is just adopting the child C. So it is not real. It is not real. So B is not a real class. That can be treated as an interface. So to reduce the problem of multiple inheritance, we are going to use one class and one interface that can be acquired by a small child, C. So this is what multiple inheritance. Remember, multiple inheritance among classes is not possible. So this is possible only when there is one class and there are any number of interfaces. That is what the concept of multiple inheritance. And next one is hierarchical inheritance. Hierarchy. See, in hierarchical inheritance, more than one class can inherit from a single class. A class C inherits from both A and B. Class C inherits both A and B. See here, this is a hierarchy. Hierarchy. There is some hierarchy. What is that hierarchy? This A is a top class and B is also another class. B is acquiring the properties of A and C can also acquire the properties of A. There is a hierarchy that is to be followed within this architecture. This is what hierarchical architecture, hierarchical inheritance. And the last one is hybrid inheritance. Hybrid inheritance. See, it's a combination of the above defined inheritances. See, there is A, B, C, D. So C and D inheriting the properties of B. It is like hierarchical. A and B, it is like single inheritance. A, B, C, multi-level inheritance, or A, B, D, multi-level inheritance. All the different types of inheritance, what we have seen, like single level inheritance, multi-level inheritance, multiple inheritance, and hierarchical inheritance. So all these together, we can see in one single architecture. We can see in one single architecture. This is what hybrid inheritance is. So can we just recall what is inheritance is? Inheritance, it is a property that is acquiring properties of a parent class by a child class, and this is for reusable purpose, and this is going to acquire the properties of methods of parent, that is operations of parent, and all whatever it is the parent is having, all that can be acquired by a child. In inheritance concept, there are two subclasses that can acquire the properties of one superclass. And the types of inheritance, one is single inheritance, multi-level inheritance, multiple inheritance, hierarchical, and hybrid. Single, there will be only one parent and one child, and multi-level, there will be any number of, there is no limit, any number of children classes for one single superclass. There will be n number of, there is no limit for this chain, and this should be like this, A, B, C, so on, A, B, C, D, so on, and said any number of subclasses can have a particular superclass, that is A, and multiple inheritance. You have to remember that it is not possible among classes in Java. It is possible in C++. Hope you have seen in C++, you can see multiple inheritance among classes in C is possible, C++ is possible. But coming to Java, it is not possible. Here, like A and B, A may be a class and B may be an inheritance. Or if B is a class, then A should be an interface. A should be an interface. If A is a class, B should be interface, and if B is a class, A should be an interface. And C, this can acquire both the properties of A and B together. For example, multiple inheritance among classes, where we can use this concept is in multi-threading concept, multi-threading programming. So there are thread class. Let us consider class A and class B. Class A and class B. And if you want to implement multi-threading concept in B, you should acquire the properties of thread class. This is necessary. So we should acquire the properties of thread class. At the same time, if B wants to inherit the properties of A also, this is like multiple inheritance, just like this. B is going to acquire the properties of A and B is going to acquire the properties of thread class also. Both the A and thread class, these two are classes, and so B cannot inherit both. And at that time, we can consider an interface instead of this thread class. What is that interface is? Runnable interface. This is a runnable interface which we can use instead of thread class. Just like whatever that is thread is having certain number of methods, all that will be there in runnable class, runnable interface also. So now we can acquire the properties of A by B, and we can also acquire the properties of thread class instead we are using a runnable interface. So this is possible. We can write like this: class B extends A, implements runnable. Class B extends A, implements runnable. Like this, we can acquire the properties of A and runnable interface. So like this is one simple example for multiple inheritance concept. So we can use interfaces instead of classes. So this is one simple example, and hierarchical, all the different types of inheritance concepts we are using in hierarchical hybrid inheritance. So this is what about inheritance concept. And let us see how to derive. So just now, an example we are seeing class B and class A. Class A is a superclass and class B is a subclass. And how to implement is, how to write the code is class B, which is a subclass. So here subclass and here A is superclass. Alphabetical order for a simple example to remember which should be first, whether subclass or superclass or superclass and subclass. For this to remember a small hint. See, B comes in alphabetical order, B comes first and P comes later. So B and B. So B should be the first class name and P superclass, that should be the second class name. This is one simple trick for any person who is getting confusion to write the classes, inheriting classes. So B is a subclass and A is a superclass. And in multiple inheritance, whenever you have any number of interfaces, you can write by simply placing a comma, runnable, and many number of interfaces you can write here. And this is a keyword extends. So whenever you are acquiring the properties of any class, you should use a keyword called extends. So extends A. And if you want to inherit the properties of an interface, you have to write implements. Implements. So for a class, you have to use extends keyword, and for an interface, you have to use implements keyword. And simple, like this class B, which is a subclass, extends a superclass A, implements runnable interface. So this is how to write code. How to write code for inheriting the properties of a superclass or an interface by a subclass or a child class. So this is simply how to derive classes. Classes are inherited from other class by declaring them as part of its definition. So for example, class my subclass extends my superclass. Here it is B subclass and P superclass. So this is simple technique to remember which should be used in the beginning and which should be later. Extends keyword declares that my subclass inherits the properties of parent class, that is my superclass. This is one simple example. And let us see one more example here. Motor vehicle, car and bike. All these two, car and bike, these two comes under motor vehicles. These two comes under motor vehicles. Generally what a car contains, there will be number of doors. And what will be having for a bike, a kick start or a button start. A car can also start with button start. We can also use here button start variable, and here also a button start variable. So for a bike also we can start a bike by using one single button, and simply like a car also we can press one single button, start and stop, and we can start a car. Bike will not be having any doors, but car can have 4 doors or 5. So based on the properties of car and bike, we can create different variables here. But these two acquire the properties of motor vehicle, which is a superclass for these two. Car will be having maximum speed, that may be 250 or 400 like that, and bike also will be having the same maximum speed variable. This can also acquire properties of motor vehicle. And string model name, car can have model name and bike can have model name. And similarly model year, when this got manufactured car and when this bike got manufactured, and the number of passengers. For a car we can change it to 5 or 6 or like that, and for a bike it may be 1 or 2 like that. The values may be changing, but all the properties are same. All these properties for a motor vehicle can be incorporated into this car or else into this bike. And methods, what may be the methods? For traveling. For traveling, car can be used for traveling purpose and similarly bike can also use for traveling purpose. So our transportation, car for transportation or bike for transportation. Whatever it may be, the number of methods, all that also can be incorporated into these two, car and bikes. These two are two different subclasses. And we can add many more subclasses for this motor vehicle, like lorries, bus, many number of vehicles, all the vehicles that comes under as vehicle properties, we can simply add as subclasses to this motor vehicle. So this is what about inheritance and method overriding. This is one of the important property comes under inheritance. Method overriding. Simply to say a subclass has the same name and type signature as a method in its superclass, then the method in the subclass is said to override the method in the superclass. What it means that if B is having something a method and A is having something a method, if B is acquiring the properties of A, that B, there is no need to use the same as A. This can implement its own. See, all the things we may not do, or we should not do, or we do not do generally as our parents do. We may work differently. That's what. So even though we may acquire the properties of A, we may work it in different models, different techniques. Just like this is an example. Consider this is an example. And see here, class B extends A. A is a superclass, and it is having a method called calculate. Calculate I equal to K. And here in the subclass, that is B, which is a subclass extending the properties of A. Here we can see I equal to 2 into K. But here, in the superclass, it is simply I equal to K. But here it is I equal to 2 into K. System.out.println, the value of I is I. So, coming to the main method, whenever we just execute a program, it starts from main method, and see we are creating an instance for this class B subclass, we are creating an instance B, small b equal to new B, and B dot calculate 12. So B dot calculate. We are just calling calculate method, and we are passing a parameter 12 to this. So which method will be called? Either the superclass method or the subclass method. This will be a question for many people. So to simply understand what is method overriding, whenever a method is there in superclass and subclass also, which is having the same format specifiers and all the parameters, same name, same return type, that is void here. Void calculate in K, there is one single parameter, and here also void calculate in K. The same signatures are there in superclass and subclass. Now, whenever this is the situation, remember, always the subclass will override the superclass. Even though the same method is there in superclass also, the subclass overrides. Now, the value of I is 24. 2 into the number passed, 12 equal to 24. So, that means that this class overrides the superclass. That is what about method overriding concept. Even though this B may be having certain different properties and it is acquiring the properties of A, B implements its own methods as it likes. That's what method overriding concept is. And next, coming to abstract class. What is an abstract class? In generic, we are going to write different classes, and simply to say, coming to the programming, if you create any class and if you place abstract keyword before the class name, it can be treated as abstract class. And to say that it is an abstract class, the class name should be preceded by abstract keyword, and also it should have some abstract methods. What is this abstract is? Abstract classes are classes with a generic concept not related to a specific class. See, for example, human beings. All the human beings will be behaving similarly. Let us consider student class. So each and every student will be having the same properties: reading, writing, listening. A student will be having these three basic properties. A student reads, a student listens, a student writes. These are the three common properties of a student. Let us consider a student Ram. So when we consider a particular student Ram, he may be making noise in the class. That may be one more added method for the particular student, making noise. So even though he makes noise in the class, making noise is one more method added to that particular student. He is a student and he will be having the three properties like reading, writing, listening. So reading, writing, listening, these are the three basic properties for each and every student, and it should be written to each and every student who are there in a particular class. For that purpose, we can create for that student class as abstract student class. So now the abstract methods like reading, writing, listening. Each and every student should read. Each and every student should write. Each and every student should listen. These are the three. But we can see different students reading in different manners. Some students may read only one time or two times or three times. Some people continuously read. Whatever the process that a student may read, but he reads. And writing, some people may write cursive writing or some people may write a normal writing. Whatever the writing that student may contain, he is writing. He will write something. And similarly listens. Some people may listen having good concentration, some people may not. But he listens, but student listens. So these are three common properties of a student. And likewise, whatever the common properties for a the subclass will have, that can be placed in superclass and we can make it as generic. That means each and every student will be having the same properties. Each and every subclass will be having the same properties as superclass, and we can make it specific and generic by using the keyword abstract. So to say the methods are abstract, we should place abstract keyword before the methods, and to say a class is abstract, we should place abstract keyword before the class. And see, abstract class is define partial behavior and leave the rest for the subclass. Just now how I told, what I told, a student will read in different manners. A student can write in different manners. But the abstract classes says partial behavior. Each and every student reads, writes and listens. So these are partial behaviors. But it leaves the rest of the less for the subclasses to provide. So we can provide our own implementation in the subclasses. This is what abstract classes. And contain one or more abstract methods. So there are three: reading, writing, listening. We can also make conform one more method as abstract method, that is registrations or something else. So we can add any more number of abstract methods. If there is at least one abstract method, we can say that the class is abstract class. If there are no abstract methods, there is no need of defining an abstract class. It is a simple technique. And abstract classes cannot be instantiated, but they can have a reference variable. It is an important point. These are the student class. See, we can't call any student a student stand up. We can't call a particular student a student stand up. The students will be getting confused. Sir is calling whom? So we can't call a particular student by the name student. We can call a particular student by his name or his roll number. We can't call by the name student. So students, if it is an abstract class, there should not be chance for creating instances. So that is what we have to remember. If the subclasses does not override abstract methods or the abstract class, then it is mandatory for the subclass to tag itself as abstract. So whenever, if you want to place any method as abstract, you should place abstract keyword before that. Okay. And why we have to create abstract methods? Just to force same name and signature pattern on the subclasses. When we create any student subclass, we should use reading, writing, listening the way how we are created in abstract class. To name. So same name in the subclasses also. To make it as a force, to make it as a mandatory thing, we are using abstract classes. To force same name and signature pattern in subclasses, just like how we are creating the superclasses. That's the thing that we are considering here. Subclasses should not Subclasses should not use their own naming patterns. So a subclass should use all the properties of an abstract class. And let us see an example. Let us see an example abstract class. I have two classes here. One is animal class and line class. So generally animal is a common generic class which will be for any animal, whatever we consider, we can say it as an animal. And see here, animal class is having two methods, eat and sound. Eat and sound. For this eat, there is a return type void, but there is, for this sound method, there is abstract keyword. Whenever we place an abstract keyword before any method, that should be there in subclass also. As it is the way how we have here, we should have the same method signature here itself. Here also there is void sound. And here there is no implementation part, but here there is an implementation part. Line rows, row. So we can say line rows. For this line class, eat also there. For this here, eat class and eat method and eat method. We can also implement eat method or we may not. It's not mandated, but for an abstract class, we should compulsory implement the method. And here there is signature here, line rows. Say for it is a line class, it is line rows like that. If it is dog class, dog barks, we can make it different for each and every different animal. So that will be different for different animals. But animal, it makes sound, that's all. But coming to the line class, it roars. And coming to the dog class, if it dog barks. We can make it different from one different animal to another different animals. This is one simple example. So we can consider here sound and here also there is sound. So we can see here clearly sound and sound. As there is abstract keyword, there is sound method here also. Compulsory it should be there. Or else there is no need to use of abstract concept. This is one simple example. And thank you for patiently listening till now. Thank you so much.